Hi, welcome to lesson 2.6, Proving Geometric Relationships. Now, this section, 2.6, deals with a little bit more of different geometric relationships, but it also introduces us to flowcharts and paragraph proofs. Now, personally, I do not care for flowchart proofs. Paragraph proofs are easy because you're pretty much just whatever it is that you're trying to prove from a two-column proof, you're just putting it in terms of sentences, so that's not really that difficult. So we're going to skip the flowchart proof of aspect, and we're going to focus on proving the concepts that they want us to prove. Okay, so right now this is on page 59. Okay, so I want you to X that out. We did that proof in the previous lesson. So all it really is put the statement and the reason, here under. It's just a flowchart. I'm not a big fan of it. So page 59, don't worry about it. Go to page 60. Okay, same thing. We already did this proof. No need to do it again. Okay, so make sure you do that because when I'm checking the journals, I don't see anything in there. I'm going to assume you didn't do it because I'm going to forget. Okay, so let's begin with page 61. Okay, on page 61, let's go over the first theorem. The first theorem is the right angle congruence theorem. Okay, and that right angle congruence theorem states that all right angles are congruent. Interestingly, problem number 1 is the proof for this theorem. Okay, the next theorem is the congruent supplement theorem. If two angles are supplementary to the same angle or congruent to angle, then they are congruent. Okay, so we're going to use this diagram that we have here. It says, well, there's going to be a very similar diagram to this one. So if angle 1 and 2 are supplementary and angle 3 and 2 are supplementary, then angle 1 is congruent to angle 3. And problem number 2 is actually going to prove that same theorem with an example for it. Okay, so problem number 2 is going to prove that one. Turn to page 62. And here are 3 more theorems that we need to know. We're not going to have a chance to fully prove all of them, but 3 we will. Okay. Congruent complement theorem. Now, guys, I strongly suggest that you really memorize a lot of these theorems because you will be using them a lot in the future. Okay, so memorize them. Congruent complement theorem states that if two angles are complementary to the same angle, okay, then they are congruent. So if angle 4 and 5 are complementary and angle 6 and 5 are complementary, then angle 4 and angle 6 are complementary. The proof for that one is very similar to number 2, or the previous one, the congruent supplement theorem. The strategy is the same, it's just instead of 180 is 90. Now, the next one is going to be if two angles form a linear pair, then they are supplementary. Angle 1 and 2 form a linear pair, so angle 1 and 2 are supplementary, and therefore their angle sum is 180. Okay, so when we're doing some of the proofs that we're going to look at today, we're going to be referencing to the linear pair postulate. And then, the last but not least, is the vertical angle congruence theorem. Okay, and we're going to be kind of proving it on number 3. It states that vertical angles are congruent. So in other words, if you have the intersection of two lines, 1 and 3 are congruent, and so are 2 and 4. Okay, so remember, 3, 5, and 4 go right there. And we're going to jump right into the examples now. So please turn to the previous page, page 61, and that is where we're going to start our first problem right there. Okay, example number 1. Okay, in example number 1, excuse me, and make sure you guys pause these videos before I start the problem so that you guys can, write it down, write down the given, write down the proof, and set up your 2 columns. Okay, so if you were writing this in your journal, you would be writing this down and then, doing your 2 columns. Okay, so what we're going to do here is we're going to try to prove that angle 1 is congruent to angle 2. Okay, Now you're probably thinking, well, isn't it obvious? They're both right angles. I mean, they got the same measurement and therefore they should be the same. Well, you pretty much just have the plan right there. Okay, so let's look at our two columns. Okay, first statement. Angle 1 and angle 2 are right angles. That's given. Well, what does that mean? What does it mean for two angles to be right angles? Or what does it mean for one angle to, be a right angle? Well, it just means that they both have a degree measure of 90 degrees. So measure of angle 1 is equal to 90, and the measure of angle 2 is also equal to 90. Okay? And that's simply by definition. Definition of right angles. That's my symbol for angles. Okay? Because I'm lazy and I don't want to write angles. So angles. Okay, so here's the thing. Do you notice how both of these equal 90 degrees? If the measure of angle 2 equals 90, and 90 equals the measure of angle 1, by the transitive property of equality, the measure of angle 1 equals the measure of angle 2. Okay, that's by the transitive property of equality. So here's the thing. The two angles have equal measures, therefore they are congruent. Angle 1 is congruent to angle 2. Okay, and this is because of the definition of congruent angles. Hence now we have now proven that all right angles are congruent. Okay, which is the right angle congruence theorem. All right, let's take a look at number 2. Now for number 2, the diagram that I have here is it's a little different, but we can use the diagram that's there or use the diagram that I already have, in this paper. Okay, either one will help us out. Okay, here's example number 2. Okay, given that angle 1 and 2 are supplementary and angle 3 and 2 are supplementary, prove that angle 1 and angle 3 are congruent. Oh, a little bit better. Whoops. Got knocked out here. Okay, so let's begin. Okay, I'm going to try to write small because I know you guys don't have that much space there. Okay, so first things first. Angle 1 and 2 are supplementary. Abbreviate, that's okay. Angle 3 and angle 2, whoops, a little too close. Are supplementary, and that's given. So what does it mean for those two angles to be supplementary? Well, that means that there's some angle measurement. The angle sum of their measurements is 180. So from this first part, measure of angle 1 plus measure of angle 2 equals 180 because they're supplementary, right? Ditto for the next one. The measure of angle 3 plus the measure of angle 2 also equals 180. Okay? And this is simply because of the definition of supplementary angles. So what are we going to do with that? Do you notice how these two are equal? Yes. Okay, so that means that these two are equal. So I'm going to try to write even a little bit smaller. All right, so the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. And what did I just do? I just applied the transitive property of equality. So then now what am I going to do? Okay, seems like this is a little bright. Okay, I guess it's better. Okay, so look at what's going to happen. You have the measure of angle 2 on both sides. I can subtract them and get the measure of angle 1 equals the measure of angle 3. What did I do? I did subtraction. property of equality. Now, because those two have equal measurements, that implies that those angles are congruent. Definition of congruent angles. Hence now, we have now proven the congruent supplement theorem. If I wanted to prove the congruent complement theorem, everything will be the same except for those 180s. They will be 90 degrees. So if you want to prove them, you can prove them. If not, then don't. Okay, so that's example number 2. Okay, let's look at example number 3. Okay, example number 3. I know the diagram's probably a little bit hard to see. Okay, so I'm just going to kind of copy it on this side. You literally have the intersection of two lines. You have angle 5, 6, and 7. Okay. Actually, let me make it look like that. Actually, that don't even look like it. Okay, I know that line goes like this, and the other line goes like this. 7, 6, and 5. And what we are trying to do is we are trying to prove that 5 and 7 are indeed going to be congruent. Okay? So, let's set up our two columns. Now, I know it says write a paragraph proof. Don't worry about the paragraph proof. Let's write a two-column proof. Two-column proofs are fun. Okay, so first step. Angle 5 and angle 7 are vertical angles. That's given. Okay, so now let's take a look at angle 5 and angle 6. Okay, so if you look at them, both of these angles here, they form a linear pair, which means that they're going to be supplementary. Okay, so we need to state that angle 5 and angle 6 are, whoops, let me get some more lead, okay, are a linear pair, okay? So they're a linear pair. And our justification, well, is just shown in the diagram. Yeah, you can say that. And for the same reason, angle 6 and angle 7 are also a linear pair. Okay, so I'm going to put them in the same reason. So here's the thing. They're both linear pairs, therefore they're both supplementary. Okay, so angle 5 is supplementary. Actually, let me do it like this. Yeah, like that. Yeah, angle 5 is supplementary to angle 6. And for the same reason here, now you can switch these two. Angle 7 is supplementary to angle 6. Okay? And this is because of the linear pair postulate. Okay? Now, here you see that two angles are supplementary to the same angle, and we just proved that if two angles are supplementary to the same angle, then they're going to be congruent. So angle 5 is congruent to angle 7, and this is because of the congruent supplement theorem, the one we literally just proved right now. Now, you're probably going to have a lot of questions during our live instruction time, and that's okay. I'm there to answer them. Okay, and we have finished our proof. Okay, that's what you had to do for example number 3. All right, let's take a look at our next example, which is a lot easier, trust me. Okay, example 4. Okay, so this is an application. Okay, it says find the value of x. Now here you can see that both of these angles are vertical angles. Okay, so this is going to equal this. Okay, so 3x plus 1 equals 148. This is not a proof. This is just an application. Minus 1, 3x equal to 147. And when you divide that by 3, okay, I have a feeling that's going to be 147 divided by 3. That's going to be 49. And that is the solution. Okay, so that's example number 4. All right, let's take a look at the next example. Okay, example 5. Yes, it's our last proof for today. Okay, what we are given is that angle 1 is congruent to angle 4, and I'm trying to prove that angle 2 and 3 are going to be congruent. Okay, so let's set up our two columns. Okay, our first step is angle 1 is congruent to angle 4. That in itself is given. Now looking at this diagram, okay, can you agree that angle 1 is also congruent to angle 2? And this is because of the vertical angle theorem. Okay, I mean, looking at the diagram, vertical angles are indeed congruent. So because of this, okay, you're going to have, okay, if 1 is congruent to 4 and 1 is congruent to 2, therefore 2 and 4 are congruent. Okay, and this is by the transitive property of congruence of angles. Now, what about 3 and 4? Well, for the same reason, angle 3 is congruent to angle 4 because they are indeed vertical angles. So now, if 2 is congruent to 4 and 3 is congruent to 4, again by the transitive property, angle 2 is going to be congruent to angle 3. Transitive property of congruence of angles. Hence now we have finished our proof. We have proven that 2 and 3 are indeed congruent. Okay, please make sure you guys are completing your extra practice, and we will see you all later.